So next is what are the APIs. So you might be hearing these APIs like the terms API related API terms, uh, API terminology in your day-to-day work. Okay, so if you see over this in this example, like we have the client who makes a request to an API, API then goes to a database and queries whatever is needed from the client, have the requested data from the database, and then the data is responded back to the client. Okay, so what is actually an API? So API stands for application programming interface. It's a set of rules and protocols that allows different software applications to communicate and interact with each other. Okay, so APIs define the proper methods and data formats which the applications can use to request and exchange the information. Okay, so they provide a proper rules and protocols that will be followed, the proper format of data, okay, which will be followed for the exchange of communication, exchange of information between the different applications. Okay, so let's take an example. Okay, so when you sign up for a new app or a website, right, so you see an option to like log in with the Facebook. So okay, so here is an API. Here's the API comes into action. Here the app or the website is utilizing the API provided by the social media platform like Facebook to authenticate your identity and retrieve the basic information from your social media profile. Okay, similarly you see the mappings and navigation, right? So like the Google Maps rely on the APIs provided by the mapping services, right, to provide accurate maps, directions, right? And so weather applications like they display the real-time weather information from various sources. They also use the APIs provided by the various weather services, right, to fetch the weather data. So like you see all these APIs like in your day-to-day activities. Okay, so APIs like are so API-led connectivity or these APIs have really become popular in recent times. So everywhere, like in your day-to-day activities, you will see the all these APIs like in action. Okay, so next comes to the REST APIs. So REST APIs, I'm sure like you might have heard about these REST APIs as well. So REST API stands from representational state transfer application programming interface. Okay, representational state transfer REST. So it is basically an architectural style, okay, for designing the application. So it also defines a set of principles for creating the web services that can be accessed over the internet. Okay, so if you see over here, the client calls a REST API and then REST API communicates with server and gets back the response. So here you see that we have the get, post, put, and delete methods which are involved over here, and sending the request over HTTP protocol. We get the response back over HTTP, and then this is the format of the response that is returned to the client, whether it can be JSON, XML, or HTTP. Okay, so REST APIs act as a medium of communication between the client and the server. So these are some of the key characteristics of the REST APIs. Okay, so first of all, just they follow the client server architecture. Okay, so here the clients and the server architecture, like these are the separate entities. Okay, client and server are separate entities. So the client focuses more on the user interface and user experience. Okay, and the server majorly like it focuses on the business logics and data movement. Okay, so REST API serves as an interface that allows client and server to exchange data, okay, over the standard HTTP protocol. Okay, then the other characteristic is the like cacheability. Okay, so the cacheability refers to the like ability of the REST API to cache or store the responses from the API, so that the performance can be improved. Okay, and there is no need to make the repeated request to a server. Okay, so let's take an example. Okay, so suppose we have an weather API. Okay, so it makes an API call to the server to get the information for the weather information. Okay, and after a few minutes, if the same call request to the server, so it doesn't make any sense, right? For the same call, for the request, the same information, we make the same call again after a few minutes. So we can cache that response which was earlier received and just return the same response. That's it, instead of making the same call to server again. So it will improve the performance and reduce the need for repeated requests. Okay. So next comes the stateless. Stateless means REST APIs do not store any information about the client request or session. So each request which the client sends, it contains all the necessary information which is needed to process it. Okay, so let's take an example like the authentication tokens, right? So when you log into any web applications or a mobile application, right, so you receive an authentication token. So this authentication token with each subsequent request to authenticate, authorize your action. Okay, the server will not store any session information. So it verifies the token provided with each request to authenticate you and respond accordingly. So how many times the number of like you make a request for authentication, so that many number of times authentication tokens will be generated. Okay, then there is a uniform interfaces. Yes, APIs will be having the uniform interfaces. So they provide a standardized and consistent way to interact with the API. So they provide a standard HTTP methods like REST, GET, or like the GET, POST, PUT, or DELETE methods. They provide a resource identification, okay, through the URIs, which are called uniform resource identifiers. Okay, so they provide standard set of status codes. Okay, where it's 200 means okay, successful response, 201 means created successful resource creation, 400 means bad request, so like that. So they have the standard set of rules, okay, which provided by the REST APIs. Okay, so that's what I wanted to cover about the REST APIs. So next is like what is integration, why it is required. So I'll hand over Venkatesh to you.
Yeah, thanks, Vikas. I'll just share my screen. Let me know once you can see my screen.
Yeah, able to see.
Okay. So I know most of you are coming from the integration background only. So you already know what is integration and why it's basically required, right? But still, a few of the folks are joining newly to the integration field, right? So just to make a justice with them, we are going to cover this particular slide. So let's understand what is integration and why it's required. So let's consider uh, we have the legacy system, okay, which is from 80s or 90s, okay, where all the communication entry and exit to the legacy system is going via messaging based system, a queues. They are using a queues to receive the message and publish message back to the originator. Then we and the other limitation they have, they could only support a XML form of data set. They are just following the XML canonical data set to get communicated with that legacy system. Okay, so now in the modern world, there is a limitation that the organization cannot get rid of this legacy system and they have to live with this legacy system only. So now they want to expose this legacy system on the modern APIs, a website, let's say a AEM website, where it support only a JSON type of data type, and it can be accessible via REST APIs only. So now we could see a gap here, right? A modern system supports REST API and JSON format, but the legacy system support XML and it can be accessed via queues only. So we need to fill in this gap using some kind of a bridge, right? So where the integration is coming into a picture, we are going with the specific integration tool like MuleSoft here, which will take a request in a JSON format on a REST API. It will do a certain transformation and it will push that request to legacy system after transform to XML format on a JMS queue. Okay. And similarly, whenever legacy system has to push back some data to a modern system, we will be having some kind of a queue listener which will accept the message in the XML format on that queue. MuleSoft will does that transformation and then send the response into send the details into a JSON format back to a modern system. So this is how we are going to create an integration to overcome the limitation of the legacy system, so that model system can expose the data available in the legacy system. This is why the integration is required, and that's what we do in the integration. Okay, so I know this is very basic stuff, but just we wanted to cover that so that everyone on the same page. Yeah, Vikas, over to you.
Yep, thank you, Venkatesh. Let me share my screen again. Okay, so as Venkatesh showed, right? So in the integration slide, so he was using MuleSoft as an integration layer. Okay, so what exactly is a MuleSoft? So MuleSoft is a complete integration solution. So it is offered as an integration platform as a service. Okay, so it provides a full range of tools and services for building, deploying, and managing integrations between various systems and applications. Okay, so it facilitates seamless communication, okay, and data exchange between various applications and the systems. It follows an API-led connectivity approach, okay, where APIs are created and managed as building blocks for connectivity. So the API-led connectivity approach helps us to promote reusability, flexibility, as well as attaining scalability also in our integration architecture. So MuleSoft has like AnyPoint platform. I hope like most of you might aware of the AnyPoint platform, right? So it's a comprehensive set of tools and services, right? So which help us to design, build, manage the integrations. So it includes various features like API designer. We have data V for data transformation. We have AnyPoint Studio for development. So all these aspects we will be going through these in the coming sessions. Okay, so apart from that, MuleSoft provides us various with the various connectors as well. Okay, connectors or adapters to connect with various systems and applications. And its MuleSoft supports different integration patterns as well, such as messaging, transformation, orchestrations. It supports event-driven architecture as well. It supports hybrid integration, so you can deploy your applications on premises or on the cloud. Okay, it provides a security and governance on the also on the for the applications. Provide you can authorize, encrypt the applications, secure. You can ensure that there is securely exchange between the systems. Okay, so in the recent times, okay, so MuleSoft has really become the widely adopted across industries and has become like a go-to choice for the organizations. Okay, uh, in today's world. Okay, so it has become like the first choice for the organizations to integrate their applications. Okay, so to summarize, so it's a complete integration platform as a service package. Okay, which would help you to seamlessly integrate your and data and integrate all your applications and systems with each other. Okay, so let's move forward. So I mentioned the word API-led connectivity. So it's just an extension to that. What exactly does API-led connectivity means? So basically, API-led connectivity means we are here. We focus mainly on creating the APIs which are reusable and those are modular pieces of functionality. Okay, which once combined, so they will form the end-to-end business capabilities. Okay, so these are the three uh, components of API-led connectivity. Okay, so first is the experience APIs, and then the process APIs and the system APIs. So system APIs generally it provides a layer of abstraction, okay, for accessing the core systems or applications. System APIs are responsible for interacting with the underlying systems, like which are the core systems like databases or the ERP systems. The system APIs are responsible for interacting with those systems. Then come the process APIs. So process APIs are largely responsible for the orchestration and combining the multiple system APIs responses to fulfill the business processes or specific use cases. Okay, so and then comes the experience APIs. So experience APIs are the real front end user face facing APIs, so which are designed to deliver the data and services for specific user experiences. Okay, so they aggregate the data from multiple systems or the process APIs, and they provide the single response to the or unified response to the end users. Okay, So these are the three APIs, the experience, process, and system APIs that is getting used in the API-led connectivity. So we'll be talking about more about these as we progress in the upcoming sessions. So this is just to for your information to understand what are the different components of the API-led connectivity in MuleSoft. Okay. So next comes to the Mule events. So Venkatesh, can you take that up, please?
Yeah, sure. Let me know once you can see my screen. I
Yeah,
hope you
able
can
to
see my
see.
screen, right?
Yes.
So so Mule Event is a very core component of a MuleSoft. It contains the information, basically what the incoming data is coming, what all the kind of variable parameters we are creating while executing the Mule flow, what all the outbound data set we are sending back to the consumer, right? So all the information will be present under the event. So let's understand the structure of the event. Okay, so we have this event. Inside event we have two basic components: messages and the variables. Okay, again messages consist of two parts: attributes and payload. Again, inside attribute we will be having the request headers, then we'll be having the query parameters, and we'll be having the URI parameters. Okay, so we'll discuss about the scope of each and every component with the help of one practical example. Okay, we'll say how the scope changes when we are within the scope of the flow, within the scope of the application, how the scope changes when we are crossing any transport barrier like HTTP, when we are crossing from one application to other application using HTTP transport barrier, how it impact on the attribute, payload, and the variables. Okay, but just on the high level to understand what is Mule event, it has consist of the message and variable, and inside message we have attribute and payload. Okay, so this is what a Mule event. We'll discuss on the scope in the subsequent slide with the help of one example. Okay, so let's understand the different type of flows also. Okay, so this flow is nothing but a connected. It's used to connect a collection of mule events. Okay, so we saw the mule event, right? It just get connected with this particular flow, which consists of a source, processing, and exception handling. So within a flow, we'll be having these three different sections. So there are three different type of flows: flow, subflow, and private flow. So we'll see this also. I'll just go to Anypoint Studio and I'll show you how the flow looks like. So, but just for the sake of understanding, flow has consist of source, then the event processor and error handler. So source are nothing but the entry point to the applications from where we will be getting the request to our application or to our flows. Event processing are nothing but the processing areas where we will be processing our request, we will be doing a transformation, right? And the error handler is nothing but the exception handling section where we will be doing a business exception handling. If any error occurred during the event processing, right, that would be handled in the error handler section. Then we have a subflow. In subflow, we will be just having a event processor. Will not have a source, will not have a explicit error handler. Okay, so we'll just having the processing. So this subflow will usually get triggered via or access via flow or private flow. Okay, so private flow, it consists of event processor and error handler. We won't have the source. Okay, so from outside world, you won't be able to make a call to a private flow. It can be either called via flow only or again subflow using a flow reference. Okay, so we'll discuss about this in detail. I'll just go to Anypoint Studio and I'll show you. So only one point I just wanted to highlight here. So to compile the Mule application or to make it run successfully, uh, required thing is here is a event processor. So event processor has to be there, then only your Mule application will run successfully. So the source and exception error handlers are the optional to make your application in the runnable state. Okay, so now let's go to the Anypoint Studio and understand about the flows and the scope of the Mule event. Okay, so as we can see here, right? So when I add HTTP listener to this particular flows flow, this is a nothing but the flow where we have the listener, a source, we have the processing event. So this, the highlighted part is nothing but the source through which we are getting a request to our application. Then the highlighted part where we have kept the logger. These are the event processors. So where we can add other components also from the parent. I can add set payload. I can add set variable, transform message. I can add HTTP requester. So everything will come under the processor, event processor section. Okay, and then we have a error handling section where we have our own exception handling logic for this particular flow. Okay, so this is the combination listener, source, event processor, and exception handling. So this is a flow. Okay, after that we have a private flow. So in private flow, will the the source will be always empty, will not have anything in the source section, and will be having the event processor and exception handling. So private flow basically get referred from another flow, subflow, or another private flow. It cannot get invoked from outside. As in, I don't have any source here, so I cannot make a call to private flow from outside of the world. Okay, this has to be invoked within from the application only. So basically, when we discuss more in the designing and implementation part, will discuss about the API get router. In that specific use case, we'll see how the private flow get used. Okay, so that we'll discuss in the subsequent sessions. But yeah, this is what the private flow look like. And at the end, we'll have a subflow. Okay, so subflow, as I mentioned earlier, there is no source, there is no exception handling. We have only event processor where we will add the component as a logger, set payload, set variable, then HTTP requester. Okay, and the subflow will get called by another private flow and flow using a flow reference. Okay, so there is a way to achieve the exception handling in subflow also. Again, when we discuss about the various MuleSoft components, right, like Triscope, then the scatter gather. In that session, we'll discuss how can be this exception handling achieved in the subflow also. Because if we see in the subflow, right, we don't have any error handling block. So there is a other way through which we could handle the exception caused in the subflow also. Okay, so this is all about the flows. Now let's try to understand the Mule event. Okay, so I have created one sample application here, which will give us the idea about the Mule event. So don't worry about this. What is this listener? What is the requester? What is the set variable transform message? So we'll cover that in detail in the subsequent sessions. But now let's focus on the Mule event. How the Mule event look like when the request comes to the application, right? Let's understand how the Mule event look like. I'm just running the application in debug mode so that we'll have the in detail view of the Mule event. Okay, so we have a Postman collection already prepared here. So this is my Postman collection. So here I'll be passing the URL. I have deployed application on 8082 port, and this is my resource path. The method is a post, and I'll be providing this as a request body, and there is no header, no query parameter, nothing I'm passing here. Okay, so let's see if the application is up. So it's still in initializing state. Once the application is up, we could see the state as a deployed. It will just spin up in another 2 to 3 seconds. So yeah, we could see the application is deployed, right? At the end, we will see the status of the application. So now let's trigger the API. So once I have triggered the API in the Mule debugger, I could see certain parameters here. Okay, so attribute, payload, correlation ID, variables, and logger. So this particular first step will let us know on which component we are. So at this moment we are on the logger, that's why we are seeing the logger name here. Then the attribute section. So in our diagram, we saw this attribute section. Okay, in the attribute we have request header, query parameters, URI parameters. So as of now we are not passing that detail, so we will not see that getting populated here. But there are some uh, uh, Postman out of the box. It just populates some headers, right? So that particular header we could see here. It's populated by Postman. That's why we are seeing this many header here. Then the query parameter section, we have it's a empty query string, then URI parameter, then we are seeing the method. So all this information is present under attribute. Then the payload. Payload is the section where we are passing the request body of our request. So the Postman we could see, right, we have passed this as a request body data set as a one to the payload. So that's what we are seeing here. And the correlation ID, it's an auto-generated fill. When we'll discuss about the MuleSoft core component, right, we'll discuss about the correlation ID, how this correlation ID is useful. Okay, how we can have a unique correlation ID across all the layers, right, like experience process system, as Vikas explained about the experience process system there, right? How we can have the same correlation ID for a particular transaction. We'll discuss on that also in subsequent session. But now, as we can see, there are no header apart from the Postman auto-generated header. There is no variable. We just have a payload. Now, what I'm going to do, I'm going to set up a variable one as a 1, 2, 3, 4, 5 as a value here. So when we go to the next flow here, we could see that the variable has been generated here. Okay, the value is 1, 2, 3, 4, 5. Okay, now once we are calling to other applications, so we are making a call, we have configured two listener within the same application. Just for simplicity I have done it. Usually we will be having a different application as an experience process and system layer, right? Just for simplicity's sake I have just added another listener here. So now just observe here, we are going to cross a transport barrier using HTTP requester. So as soon as the request would made to this particular HTTP requester, the control will comes here, and then we'll observe how the scope of variable, payload, and attributes is getting changed. Okay. So now, and again another part, if I can show you in the requester, we are setting up some headers also here. So we are giving the header one value as a value one. Okay. So let's go to the call. Now we could see that the request comes to the Mule event flow one to the next application. And as you can see here, the variable which we have created in the previous flow, Mule event flow, that is gone. Okay. So with this, we could understood the scope of the variable. Okay. So variable is available within that particular scope with before, so it won't get carry forward once we are crossing the transport barrier. That's why the variable is gone here, and we could see the payload has been populated. The same payload is carry forward from the previous layer to the this one, even we are crossing the transport barrier. And then on the attribute section, we could see that the headers, right? So the header one value has been populated here. Okay, so now what I'm doing, I'm just setting up the new variable var1 with the this value. Okay, so we already had the var1 in the previous mule event flow. This with the same name, I'm setting up the same value, the different value, and we could see. So we got a timeout because I have followed the default timeout as a 10 seconds. So let me just change that to. So let me change this response timeout to like 1,000 seconds. I think this is in the millisecond if I'm not wrong. So give me some higher value here. Okay. So I'm just saving the application. It will get saved. Let me just re-trigger it. So far what we have seen, right? The scope of the variable and the scope of the payload. So whenever we are crossing the transport barrier, the variable will gone and the payload will carry forward. And whatever new attribute we are setting up in the HTTP requester, same will be carried forward to the new application or new flow. Okay, so that's what we saw. Now what I'm doing in this flow, I'm just setting a var1 to this strip for 5 times 2 values, and I'm just updating the payload to data set to 2. Okay, now once the processing is completed, we will see what response we are receiving back to the Mule event flow. Okay, so that response will observe, and there again will clarify the Mule event scope there. Okay, so let the application trigger. Okay, it's up and running. Let me trigger the API. So let me just jump on to the next application. So here I'm setting up the payload. I have set up the variable. So variable we could see as this one, and the data set as a 2. Okay, and the attribute is having this values. Okay, so now when I go to this one, right? So again, if you see the variable section, the value shows as 1 2 3 4 5. So the variable what we have created in the Mule event flow, in the source flow, right? So that variable is still exists when the response come back to that particular application scope. Okay, so whatever value we have set up in this particular variable, that's gone, and we got our original variable value. After that, the payload is the data set 2, right? So the original payload was data set 1. Now we have a data set 2. So whatever request we are setting up here, it will come as a response back to the original flow from where we are making call. And as far as the attribute, we could see the header value which we have set it up at this requester has gone also. So with this, we could see that, right, the variable is on the application level, the attribute, the request attribute, what we have set up at the requester side will carry forward to the destination along with the payload. And once the response come back, so the originated request and attribute will be gone, but the set of the variables, the variable would be continue as is. Okay, so this is what we understood about the Mule event. So we have just created one interesting slide just to understand, just to test your understanding about the Mule event. Okay, so you can just unmute yourself and just try to answer these questions. Okay, so now basically this is application one, where once the request got hit from the postman, we have the, so as you can see right here, so this is the attribute, this is a payload, the mule message and the variable. Okay, and same thing we have forwarded here. We are tried to showcase here. So we have the header as a ABC. Okay, a request header as a ABC, the payload as a PQR, and the variable is null. Okay, so as soon as request comes in on the event source, we are seeing these many details. Okay, now in the event processor, we have set up the variable as a ABC. So now can you tell me, can any one of you tell me how the mule event look like on this particular event processor after setting up the variable? You can unmute yourself and you can try to explain, guys. Anyone? Let me
Can you
just.
repeat the question?
So the question is like, we saw how the scope is getting varied for mule event, right? In the example we saw about how the mule event changes, right, on the scope, variable, payload, and attribute. So what I'm trying to do here, what we are trying to do here, we are trying to have some exercise here. Okay, so I got a request to my mule application, and the event is look like attribute is ABC, payload is PQR, and the variable is null. So now in event processor, I'm setting up the variable as ABC equal to 123. So now can you tell me how the event will look like now? What changes will happen to the event? So this one I'll just tell you. So the event will look like this. So attributes stay as is ABC. Then we have PQR as a payload, and the new variable gets populated as a ABC equal to 123. Okay. Now in the next step, we are setting up the header as a 123, and we are making a call to another application via HTTP requester. And someone tell me how the event will look like now.
Now ABC, sorry, header, whatever parameter we are setting as 123, it will populate, and
Yeah.
variable will be ABC and PQR message.
Yeah, exactly. So that's right. So we could see the header as a 123. The payload is as its PQR and the ABC equal to 123. So we will make a call to other application, and the application will receive the event source, and the event will look like this. Okay, header is 123, then the PQR is the payload, and the variable state is null. Okay, so as we saw in our application, right, in the example, so a variable will not carry forward to the application, another application where when we are crossing the transport barrier. Okay, so the event will look like this. Now tell me, in this particular event processor, we are setting up the variable as a ABC equal to 445, and the payload is my data. So how the event will look like now, guys?
A header is coming as 123, that will stay 123.
Mm-hmm.
Variable whatever you are populating here,
Mm-hmm.
the variable will become that, and then PQR message.
Okay, exactly. So we'll be having header as 123, then payload will override to my data from PQR, and the variable will set as a 445. Okay, so now we have done some event processor, the some stacks XYZ XYZ like that. Okay, now the control comes to this event processor. Now, can you tell me how the event will look like on this particular last event processor?
Header 123, my data and variable null.
Sorry.
Wrong.
Okay. Yeah. So header would be null. Okay. My data and ABC would be 123. So as I said, right? So variable state. So as soon as the control comes back to your original application, so whatever variable we are creating in that particular scope of the application, the same variable will be available after the transport barrier. And whatever variable we are creating in the scope of another application, that will be lost when we cross the transport barrier. So if you observe this, right, before we make a call to this particular application 2, the event was like PQR and ABC equal to 1 to 3. So ABC equal to 1 to 3, that was the variable. And when we go to this particular application 2, they have set up the different variable, and we lost the original variables created in the application 1. Now the control comes back to application 1 from application 2. So whatever variable was created on the application 2 will get discarded, and we are back to the application one scope. So whatever variable we have created prior to this particular transport barrier, right? Prior to this particular event processor, the same variable will carry forward to that particular application. Okay. Now on the header 123. Okay. So header 123 was the request header came from application 1 to application 2. Okay. Now from this particular event processor, we are sending a response back to the application 1. So what we saw header 123 was the request header, not the response header. So that's why when the response goes back to application 1, the header will be lost, because now application 1 will look for the response header, not the request header. And here on the event source, we are not setting up any response header, right? So that's why the header is null here. Okay. And only thing, whatever response we are setting as a my data as a payload, right? So the same would be carry forward to the application one. So this is how the Mule event changes when you just go step by step on the Mule event processor when you cross the transport barrier. I hope this makes sense, guys. You clear, right? Why the header is
Yeah,
not getting populated and why the
yeah,
variables
because
use
it
one, two,
was a
three.
response header. Yeah.
Yeah, exactly. Yeah, I think if that is what about Mule event. That's from my end. Vikas, over to you.
Yep, thank you, Venkatesh. I think it was a really good explanation. Okay, so that's what we wanted to cover in this session, guys. Okay, so any questions, guys? Would like to take it up? You can unmute yourself and ask the questions.
So, when you are giving any assignment, then how you will cross check that whether we have done it right or not?
Vikas, should I take that up?
Yes, yes, please.
Yeah. So what we are going to do, right? We are going to create one trial account. Okay, Anypoint platform trial account where Vikas and I'll be having the organization level permission administration, and we already have your email ID, right? So we will be inviting on you on that email ID. So you guys have to join that particular trial account, and whatever assignments you are going to do, right? You need to deploy that as a jar on that particular trial account only. And Vikas and I'll be going to download that jar and we will be validating that.
Oh, okay.
Makes sense, right?
Yeah.
Any other questions, guys? So I'll take that as a no then. So guys, we'll be uploading a recording of this session on our YouTube channel, which is Your Integration Buddy. You can see on my screen. So you please follow this channel on YouTube, and then you follow us on medium.com where Venkatesh writes the blogs as well. And you can then follow on our integration, Your Integration Buddy on the LinkedIn page as well. Okay, so we'll be keeping on publishing the questions related to the sessions on our LinkedIn page as well. Okay, so there will be MCQ questions, so oh, you can attempt those over there as well. Okay,
Okay.
so yeah, so that's pretty much we wanted to cover in this session. Thank you very much, guys, for your time. So we'll see you in the next session next Saturday, and I'll publish the link to join this session on the on our Telegram channel. Okay.
Yeah.
Okay.
And meanwhile, if you have any questions, right, you can just post it on